Okay, so now we are looking at the arithmetic coding. So arithmetic coding is one of the technique of compression. Okay, so this one is based on the statistical as well. So let's say you want to send a message, okay, of SWISS underscore miss. So arithmetic coding, you have to transform it into this table where you will get the frequency of this message, and for each character you will get the probability. So for example, the first S, character S, it occur 1, 2, 3, 4, 5. So the frequency is 5. Okay, W only once. Okay, I 2 times, occur, M and underscore also 1 time. So from this frequency you get the probability. So the total character is 10, so the probability is 5 over 10. Okay, 1 over 10. Okay, so from this you will get this interval. So why do we need to get the probability is to get this interval. Okay, so this is the interval. So we start from underscore. Okay, underscore, the size is 0.1, so it start with 0.0 to 0.1. Okay, the size, the length. And this one also 0.1, so start with 0.1 plus 0.1. So the interval is from 0.1 to 0.2. So same goes to here, 0.2 to 0.4. 0.4 plus 0.1 is 0.5, and the last one is 0.5. So this the size is 0.5, then 0.5 to 1. So from this interval, we can visualize it in this figure. Okay, means that from 0 to 0.1 is the underscore. From 0.1 to 0.2 is M. Okay, I 0.4 to 0.5 is W, and 0.5 to 1 is S. Okay, so from this interval, you will encode each of these character. Okay, so to encode, we start with the S, character of S. So for each character that you want to encode, you have to get the high and the low end. Okay, so how to get the H and L is by using this formula. So for a start, we assume that the current interval is from 0 to 1. Means that L is 0, H is 1. So from here, you calculate the L is 0, H is 1, L is 0, multiplied by 1.0. What is 1.0? Is based on this table, this interval. Since you encode S, so the CSI plus 1 for S is 1. So 1. And the low, you will take the CSI. So for CSI, S is 0.5. Okay. So then you will get the new interval. Okay, 1 multiplied by 1 is 1. 1 multiplied by 0.5 is 0.5. Okay, so this will be the new current interval that you have to refer, okay, to the next character to be encoded. So next we move to the second character, which is W. So W, then again you have to identify the H and L as well. So H and L, the L now is 0.5, no longer this current interval. So now you are referring to the previous character that you encode. So means that this is low, this is high. So L is 0.5, H is 1.0 minus 0.5 and multiplied by, so now W, the SI plus 1 is 0.5. So 0.5. For the low, the same, multiplied by CSI for W, which is 0.4. Then you will get 0.70 and 0.75. Okay, so then you continue until all character been encoded. Okay, as in your slide. This, so you have to continue to get the new interval for each character that you want to encode. Okay, S, W, I, S, I, underscore, M, I, S, S. So lastly, you will get this interval. Okay, so this interval, we will encode it. Okay. Okay. So let's say you already encode the last one, which is S. So this is the new H and L. So it means that you can take any numbers from 0.7175335 to 0.7175350. So any number within this interval. So either you take the minimum one or in between. Okay, and then you will calculate the entropy. Okay, so how to calculate the entropy? So this is the V. V is the minimum. So this is V. V is from 0.375 to 500. So to calculate the entropy, you have to get the cumulative multiplication. Okay, for this Swiss miss. So means that you have to calculate the R. R is product of the probability. Okay, so as the probability is 0.5, then 0.5. Next is W. W, the probability is 0.1 multiplied by 0.1 until S. S is 0.5. Okay, so you will get 0.0000125. So this is the interval size. From this interval size, then you can calculate the entropy. Entropy is the estimation of the number of bits that you will encode. Okay, so M is negative log 2R. Okay, or equal to negative log 2 0.000125. This one. There will be 50 here, should be 245. So it equal to 19.6 and approximately around 20 bits. Okay, to encode this. Okay. Next, after you calculate the entropy, you have to generate the binary code. So as been calculate, and the entropy is 1.96 bit per character. Okay, so for this, you will use 20 bits. Okay, based on the number of bits. So how to transform into a binary code, okay, is by taking the any value from L to H. Okay, any value from L to H. For example, here we take 0.7175347. So this is base 10. Now you are generating a binary code. Then you have to transform into a binary, which is base 2. Okay, so as been calculate, okay, the number of bit is 20. Then you have to calculate until 20 bits. How to transform from 10 base to 2 base? Okay, so this is how you have to transform. So for example, you take this number, okay, you have to transform into a binary. So you take this decimal number multiplied by 2. Since you are transformed into a binary, then multiplied by 2. So you will get 1.43814. So the number before the decimal will be the first bit to be encoded here. Okay, so next 0.43506814, you multiply by 2 again. Then you will get 0.870. This. So the next bit will be 0. Again, continue by multiplying this number with 2. Then you will get 1.7. So next will be the 1 to be encoded. So you have to continue until 20 bits. That's why you get this one. Yes. Okay. So the code length M is 20 bit. So the bit rate is 20 bits multiplied by 10 characters. So the 10 characters is the Swiss miss. Okay, then you will get the bit rate is 2.0 bits per character. So compared to Huffman, okay, why arithmetic is produced is based on the problem of Huffman. So by using Huffman, you will have the bit rate of 2.2 bit per character. Okay, although the number of bit is less, if you multiply by certain number of character, then the size will be larger. Okay, so this will be the output, the encode of Swiss miss. So this will be the encode for the Swiss miss. Okay, then after you encode, then you will do decode. Decode is where you will inverse your encode to be as the original, as the input, which is you have to transform it as a Swiss miss. So how to decode? So you will take the V just now. Okay, so let's say you take 7175335. So this one is fall under this range. So means that the first that you will decode is the character of S. Okay, so then remove the effect of S from 0.717 by subtracting the low value of S. So means that 0.7153375 you subtract with the low end of S, which is 0.5. Then you will get this one. Next, you have to divide, okay, by the width of range of S, okay, which is 0.5. Then you will get this one. So 0.435067 falls under W, this range. So next to be decoded is W. Okay? W. So the process repeat until 0, until you get this number 0, or the known length of message is reached, or you will get the SWISS underscore miss B decode. Okay? So this is the how you do the decoding. First you have to subtract, and then you have to divide. Okay? So for each, at the end you will get 0, and all the characters already been decoded. Okay? So as a conclusion, so what is the arithmetic coding actually from the observation? So the arithmetic coding involves all the arithmetic operation. What is arithmetic operation? It will involve the addition, multiplication, subtraction, and division. Means that when you encode, you will involve the addition and multiplication, while when you decode, you will involve the subtraction and division. So that's how the name of arithmetic coding came. Okay, so that's all.